Can you see the screen?
Not yet. We can see yours. Okay. Can you move to presenter mode? Perfect.
Yes. Excuse me, my laptop is extremely slow, so sometimes the picture is not smooth. But right now, you see it.
Hold on 1 second. There's some issue with the audio. The video is correct, but the audio seems to have some kind of echo.
Pan, could you just try turning off your video temporarily and just having your audio on for better internet connection?
Well, I cannot hear you clearly because my laptop, I think, is extremely slow, and your sound is not smooth for me.
Can you turn off your video?
Yeah, turn off my video, okay. Yeah.
Hopefully the internet is better. So let's start. If we cannot hear you, we will try something else.
Now,
Thank you.
Can you see the screen? Is that correct?
Yes.
Yes.
Sorry, is there anybody there?
Yes, you can start. We can hear you well. Hold on. Now you left the presenter mode.
Maybe I can. Hi, Pan. Can you hear us?
I cannot hear anything.
Okay. Can you?
Okay. Oh, now I can hear. It's normal.
Yes. Can you? Yeah, you can go into slideshow. Yes.
Okay. Sorry for the problem.
No worries. Yes. And we're waiting for it. Yeah, it's now in slideshow. You can start.
Okay. My name is Pan Fang. Right now, I'm a PhD candidate in TU Delft. My promoter is Hans Hoffman, and my co-promoter is Xiaoli Jiang. Today, I'm gonna introduce my PhD topic, which is development of a feasible structural model to predict the mechanical properties of dynamic power cables. The presentation will be divided into 4 parts. First, self-introduction. Second, PhD project. Third, research progress. And the last, published articles. Right now I'm in the department of 3ME. I studied my PhD from September 2019. Let's look at the background firstly. A key component in the wind farms is the power cables. Power cables can be divided into 2 different styles. One is the static cable, and another one is the dynamic power cable, which is shown by the yellow line in the image. The static cable is lying on the seabed, and normally dynamic power cable is hanging in the water. Newsletter in 2016 stated that 77% of the total global cost of offshore wind farm losses are relevant to subsea cable failures. And one of the problem is the mechanical behavior of the cable is difficult to predict. And according to this, to latest European projects, BTIP Wind and Common Trust give 2 recommended research actions. One of it is validate and develop cable modeling tools and methods for cross-sectional analysis. And the another one is research on different configurations of dynamic power cables. Because as we all know, the cable is project-based or case-based, and it is customized based on different projects. It has different configuration. So it will be a big contribution to have a modeling tool to help us to facilitate the modeling process. Now this brings us to the cable configuration. Power cable is a multi-layer structure with different materials and different geometries, especially the geometry of the armor layer and conductor. The armor layer is composed of numerous helical wires winding around in one direction, but in some cases, the power cable is composed of 2 layers of helical wires. So the helical wires in that case would wind around in 2 opposite directions. And as for the conductor, which is also composed of numerous helical wires. And the previous study normally simplify it into a solid component in the numerical model. And this needs more research. So whether this simplification is correct or whether it is reasonable as compared with a real cable, and this deserves more attention. And then the fourth problem is the stick slip phenomena, because the power cable is unbounded of each component. When the friction force reaches its maximum dynamic friction force, the stick slip phenomena would appear within the cable. And the fourth problem is the mechanical thermal problem. According to the literature, for example, the images here shows the Young's modulus is highly dependent on the temperature of the insulation layer. And we all know that the insulation layer is closely contact with the copper conductor, which would generate a lot of temperature in the practical engineering. So the problem with regard to the insulation also deserves more attention. And at the last, as I said, that the power cable is customized. So if we can design a model that can help us to facilitate the modeling process and the calculation process, that would be a very interesting topic. So in conclusion, the research topic is development of a feasible structural model to predict the mechanical behavior of dynamic power cables. And the work is divided into 3 parts. The test is used to validate the analytical model and the numerical model. Well, the analytical model will help us to simplify the model in a reasonable way. And the analytical model will put into the numerical model. At the last, the numerical model will give the mechanical behavior of the cable. For example, the stiffness of the cable, as well as the stress and strains of the main components inside the cable. For example, the stress of the helical wires. That is what we need to pay attention to. The tests include power cables under tension, power cables under bending. These 2 parts have already been done. We also need to do some tests with regard to the power conductors under bending, under tension. Except that we also need to do some material tests, because like the plasticity and elasticity information of the materials are necessary if we want to build a numerical model. And at last, the friction test is necessary if we want to obtain the friction coefficient within the cable. And similarly, the analytical and the numerical model will study the power cable under axisymmetric loadings. Well, axisymmetric loadings includes tension, torsion, and external pressure. And this part have already been done in my PhD project. And then power cable under bending. And this is a very important issue that I need to solve. And then power conductor under tension and bending. Also at the last, the coupled influence of mechanical and temperature effects, especially with regard to the insulation layer. Now, this brings us to the test. The specimens used in the test is a 3-core power cable. The diameter of the cable is 150 millimeter. It composed of 300 millimeter square power cable, and also some steel strands are also used in the cable. Now, the first is the tension test. The power cable is totally fixed by 2 supports. The degrees of the freedoms of these 2 supports are totally fixed, except the degree of freedom in the axial direction. So where a tension force is applied in the axial direction. At the last, the test can give us the axial strain and axial force relation. And notice the cable is pulled and relaxed repeatedly. So it has 2 phases. One of the phases is loading phase, and the another phase is unloading phase. The second test is the bending test. Also, 2 supports are used to fix the cable. These 2 supports are corresponding to point A and point D in this image, except that 2 rings are used to hold the cable. And these two rings are corresponding to point B and point C. The rings can move together in one direction and it will move into another direction. So repeatedly, the cable will bend in one direction and then bend into another direction. Three displacement sensors are put on the cable to record the displacement of the 3 points. And according to the displacement of the 3 points, we can have the curvature of the cable calculated. So at last, this would give us the curvature and the moment relationship of the cable on the bending. The second work is the numeric model, which has already been built in RQs with regard to 1 core power cable and 3 core power cable. So these are the preliminary simulation results from the model. These two images gives us the missus stress of the 1 core power cable of the cross section of the whole cable, and this image gives the the axial force on the wire layers. At last, the analytical model also can generate the axial strain and the tension force relationship, and it is compared with the numerical result. So axiometric loading also include the torsion. So this model also generates the twist angle and the torque relationship. And notice there are 3 lines here. The red line is the analytical result. The black line and the blue line are all numerical model, but it is under 2 different situations. One of them is frictionless. That means that we didn't consider any friction within the cable. That means each layer are freely to slide with each other. It is shown by the blue line. And then another situation is a rough situation. That means each layer are totally attached with each other. They cannot slide with each other. In this case, we also can think that the friction coefficient has reached the infinite maximum value. So we can see from this image that after a certain point, the 3 curves starts to have a very obvious difference. That's because the layers within the cable starts to sliding with each other. So if you want to know the details of the analytical model and the numerical model, as well as the result from these 2 methods, these results has been summarized in this paper, although it is still under revision, but I guess in 2 months it will be published. So yeah, that's it. Thank you.
Thank you, Pan. Our last speaker from the session on electrical systems is Manuel Rentschler from WavEC. His presentation is called Layout Optimization and Bending Experiments. Please post your questions in the Q&A function. Welcome, Manuel.
Hey, Amorina. Can you already see the screen?
Yeah, it's perfect. You can go ahead.
Okay, wonderful. So then, hello everyone. Welcome to my second presentation, actually, already for the semester. This time I would like to talk to you about the dynamic cable layout optimization that we have been researching at WavEC now already for quite a while. And yeah, I'd like to start with a fact that has now been mentioned by multiple speakers before me in this session, that cables are quite susceptible to fail, and thereby causing a lot of economic damage. And yeah, the numbers that you see there are almost more or less similar to what you see displayed here. Just note that these numbers, they are for static cables and inter-array cables in fixed offshore wind farms, because well, we just don't have a lot of floating wind farms yet for a long time. But if you look at the root causes of these failures, we can see one is mostly related to design and manufacturing. And the others are more likely related to errors in the installation process or the unearthing of the cable, and then it starts to move around. So you see a big part of the problems is actually when the cable is moving in motions that it is not supposed to do. And of course, that is a special challenge for dynamic cables that, as the name says, they are naturally moving around because they are exposed to the motion of the floating platforms, exposed to excitation by waves and currents. Now, also with an emergent technology, always there is a problem that there is a lack of research experience. While I have the impression that that the research has recently picked it up in the years, what we also see here in the panel. But yeah, we still have also very limited field experience, of course, because as I said, well, we don't have a lot of floating cables around yet. And at this point, our research wants to step in, and we wanted to see how can we optimize the dynamic behavior of the cable in order to reduce the risk of mechanical failures and thereby finally increase the project's reliability and the profit that you're getting from your asset. Now let's have a look at the cross section of a dynamic cable. And as we've seen before, this is looking quite complex. So you see, besides the conductors that are formally the ones responsible for the transmission of the energy, there's a lot of other layers around them, like screens, insulations, fillings, and protection layers. And as so often with complex systems, there is a lot of things that can go wrong. And here are some of the typical cable failure modes that we can encounter. So if you're pulling too much on the cable, it may rip apart. It's also not good if you're compressing the cable, because then, because of the helical structure of the cable, you can get this phenomenon called bird caging. So you get a bulb shape here. If you're bending the cable too much, that is not good. If you're bending the cable not in a very large amplitude, but continuously over a long time, this is also not good, because then you may get micro ruptures in the conductor cores. So this is a typical fatigue problem. When the cable is ripping on the seafloor, then you get abrasion. We have the insulation problems, and then we can have all kinds of other unforeseen impacts that not necessarily need to be a white shark. It can also be just an anchor hitting the cable dropped from a ship. But in the layout tool that I would like to present you, we are focusing first here on the top part of these mechanical failure modes. And so how are we going to do that? We've already heard in earlier presentations that a very popular layout of the cable is the lazy wave. And by lazy wave, we mean that we have the cable that is organized here in this nice wavy shape, where we have a buoyancy section in between that is effectively decoupling the motions from the floater that the cable experiences here at the top, and from the motions here at the touchdown point at the bottom. Now, the question is, of course, how and where, how many of floating modules do I need to apply? Because depending on that, my cable can look very different. And we have developed an algorithm, actually a genetic algorithm, that is making this decision for us, that is running and is optimizing the number and the location of those buoyancy elements. And how you can basically imagine that, we have the whole cable discretized into small parts, and every part is either marked as 0 or as 1, while a 0 is just standing for the normal cable, and the 1 is standing for a position with the buoyancy element. And yeah, then on this string of 0s and 1s, this genetic algorithm is performing its optimization procedure, and over time we get an optimized shape. And now you may ask, what is optimized, or what are we optimizing? And there we can see here on the bottom right side, we can actually optimize multiple design criteria at the same time. And here in our case, we took into account the fatigue damage, the bending of the cable, the tension in the cable, and even the number of the floaters that we apply in total. How do we apply all these design criteria into one optimization function? Well, that is here the fitness function that you see. It is just where you can basically see the sum of the normalized design criteria. Here we have the number of buoyancy elements. Here, this is the maximum tension. This is the maximum bending. And then we have the fatigue damage. And the fatigue damage is out of all those 4 parameters, definitely the most complex one to determine. And I want to give you a quick impression on how we do that. So this fatigue assessment is mainly based on a material curve that you can see here on the side. So typically you have either tension cycle curves, or here it is actually a strain cycle curve. And basically this curve is telling you how often and in which amplitude you can extend the material before it breaks. And so the idea is over the simulation of our cables, we are summing up all the amplitudes that we are bending, calculating partial damage values, and then in the end just summing them up all over the lifetime. And this is quite a complex process that involves many steps. It starts all with an OrcaFlex simulation, and then we extract basically the curvature history, then convert it with the curve that you have. We convert it into the strain inside the conductor cores, then with the curve, the material curve that you have seen before, we convert it into the damage values and then sum them up. So in this process, there are quite some assumptions and methodologies involved. Some of them are well validated, and those are the ones that you can see here in light blue. Some other of them, they are not well validated, and well, we actually still wanted to validate them. And this would have been the point where I would have liked to share with you actually already results from our cable bend tests, because from Marinet 2 we got the grant for cable bend tests together with Catapult in the HV labs. These tests, they are still in progress, as is the evaluation, so I cannot disclose anything at this moment, but therefore I'm very grateful to Pan that he was at least speaking before about cable bend experiments. So we hope that with something similar to that, we can actually validate some of those assumptions. Instead, I will continue with the umbilical tool and actually tell you what we imagine, how we can apply this tool in practice. And one thing as which we have already used this is just a design tool. Yeah, at the beginning, before you even construct your asset, you can run the simulations and then optimize the layout and then estimate the fatigue lifetime. So this is at the beginning of the project life cycle, but we actually also seen application during later stages of the project life cycle. For example, as an asset management tool, especially if you apply sensors to the cable and you are able to monitor the cable like in real time, how it is bending, how it is moving. Then you could create by that an entirely a digital twin and evaluate the fatigue in almost real time. Or if you're monitoring the environmental conditions, then as in a kind of hindcast analysis, you could evaluate how much how much your cable was actually exposed to environmental conditions. For example, if they have been very different than what you expected in the design. And also, I mean, we have now turbines growing bigger, projects growing bigger. So in the moment, we have quite fast changing pace in the industry sector. So it may be that actually, like that assets are growing bigger and bigger, and then maybe the cables, they are only used for 5 years, and then there's coming something bigger, something new. And if you know the conditions that the cable was experiencing during those 5 years of project lifetime, you could use a tool like ours to estimate what was the fatigue damage that it has experienced, and what is the remaining lifetime that you could guarantee for that cable. So this is also interesting for reselling or for reusing the cable. This is just a short picture to a case study that we have already done. This was actually a feed study, so a design study for a client. It was very nice for me to see because I developed this umbilical tool in my master thesis, and then after 3 years only, we actually were able to apply it in a real commercial service. So basically, we compared 2 different cable configurations that were optimized and then ran the full cases, like the ultimate limit state, fatigue limit state, with marine growth, checking if the cable is not clashing with the mooring lines, and all those things we can do now thanks to the tool and the optimization process. So summarizing, we have this optimization is quite a novel approach. It is highly customizable because in the fitness function you can basically pack every parameter that is interesting to you. And we have observed that compared to the typical or generic layout of a lazy wave, we were able to achieve more than 50% around of fatigue reduction thanks to the optimization algorithm. I have presented you that there is possibilities for a wide applicability throughout project lifecycle. And ultimately, we hope that tools like this reassure investors and increase the bankability of future floating wind projects. If you're interested into more details, please have a look at those 2 papers that are published open source, so freely accessible. The more comprehensive one is actually the one from the older one from 2019. The other one has only been published later because there were some reviewing the review process took quite longer than expected. So yeah, I recommend you this 2019 paper especially. So thank you for your interest, and yeah, looking forward for feedback in the Q&A session. Yeah. Thanks.
Thank you, Manuel. We will now start the Q&A session. Please, Pan, turn on your video if you want, or if you can. We don't have any questions yet on the Q&A function. I do have a couple of mine. Please, if any of the other panelists have any questions, jump in. You both mentioned, well, sorry, Manuel was the one that mentioned more biofouling. How can you, are you either of you able to, by using the different sensors on the cable and control systems, are you able to know when the bending is because of biofouling that is attaching to the cable and when it's because of the currents and other circumstances?
Well, actually, I mean, the biofouling is something very difficult because this is like, of course, depending on the location exactly. You have different species and everything. But one thing they always have in common, and biofouling basically means added mass. Yeah, so it makes your cable heavier. So in fact, usually what I've seen from experience in my simulations is that the added mass makes the cable actually bend less, or it makes it, because it starts to move less. But the added weight may increase the tension in the cable, or yeah, surely increases the tension. So it's maybe actually more problematic for the minimum braking load than for the minimum bend radius, I would say. Okay. Now differentiating that between what impact is coming from currents, what is coming from the waves, yeah, that is difficult. In simulation software, you can of course separate it. There are, like, for example, software like OCAFlex tells you exactly yeah, what is the wave load, what is the current load, but in real life, to differentiate that between with simple sensors, that could be quite tough. But I'm also not the experimental guy, so maybe Pan can know more about that.
Pan, do you want to add anything more?
Sorry, I don't know the problem. What's the problem?
I was just asking, for example, you have a cable already installed offshore, and while you're monitoring the cable itself with the sensors and everything you have there, if you could differentiate at some point whether the new movement or the movement of the cable was because you suddenly have a lot of biofouling attached to it, and that is what is changing the cable dynamic, or if it was because of other conditions.
Well, I think this problem is belong to the global study of the power cable, and what I'm focused on is the local part. So I think Manuel would be a professional about this problem.
Okay. So we have one question in the Q&A. 1 second. Thank you, Manuel. Have you or your company done anything about conditional monitoring of the cable? And the cable is case-based. Is there any generic cable model being used?
So thanks for the question. Indeed, the conditional monitoring is something that we envision, but it is not something that we have tried yet. We maybe because I don't know if there is it's in general difficult to get cable data at all. So I think there is nothing like publicly available to get like a real cable somewhere in the water equipped with all the sensors we need. Yeah, something like this it doesn't exist yet. for open use, I would say. So unfortunately, we haven't done something on that, but we clearly could do if we had the conditions and the input data, of course. Cable is case-based. Yes, very much. Well, for our simulations, we have actually used a cable that is close to close to a real cable that was developed and that we internally had access to the data. But then once again, like manufacturers, they are very restrictive with their data. So this is a real problem. Usually for design processes, then usually you know more or less for what you design, so you know more or less the cable properties, but sometimes you even you need to make estimations, and you can only validate them later in the feed study or when you actually procure the cable. And if the data looks very different from what you assumed in the beginning, then well, you have to rerun the analysis. It's like in every design process, it's iterative.
Okay, thank you. I have also one question. Now that floating offshore is moving to waters all over the world, have you ever tested the effect of temperature on the cable? Because certainly it's not the same water temperature you will have in the North Sea than you will have in Costa Rica, for example. And we have a speaker later. Have you ever tested any effects of degradation related to water temperature?
Not yet. Where I think in our umbilical tool that would go into is probably the material curve. Probably you would need a material curve for different temperatures. And it is not only the water temperature that will actually be different. You also have to keep in mind that when the cable is loaded with current, then you will have the temperature from the current, right? So usually I think that the operational temperature is it's quite higher than the water temperature. It's I don't know, 70, 80 or even higher degrees. I don't know if someone is here that knows those values better. But yeah, temperature definitely has an influence. Like copper, the typical conduction material is highly dependent on operational temperature. So this is definitely something that one should take into account.
Okay, I was asking also because certainly the visibility as well in the water goes deeper in places like Costa Rica and other countries near the equator. So definitely that would also add into the degradation of the cable, the outer part of the cable. Yeah,
for sure. Yeah.
Okay, thank you. Unless any of the other speakers will have any other questions, we can close the session on electrical systems. And I will give the floor to Danielle. She will be introducing the next session on project management.
I'm muted. Thank you, Amorina. I think we should wait another 5 minutes before starting the next session.
Okay.
Yeah.
Yes, we can make a short break, 5-minute break, and we'll get back at 1:45.
Yes.
Okay.
Okay, I think we can open the session on offshore wind potential.
Daniel, sorry, 1 second. We just switched it because we'll be starting with project management. Apologies for this thing. Yeah, so we'll start with Amorina first. Yeah.
Okay, I see. Okay. Well, then it's my pleasure to introduce Amorina Gonzalez Armayor from WavEC, and she will be talking to us about the use of project management to reduce costs. I think so. It's exactly 2:45 now. So please, Amorina.
1 second, let me know if you can see the full screen. Can you see it now?
Yes.
Okay. As you all know, the summer school is part of the TWIND project, which is a European project. And within this project, our main aim is to promote offshore wind here in Portugal. One of the main activities we started working on due to the COVID was preparing a supply chain matrix for offshore wind in Portugal. We already have the first version online on the project's website, and we will soon have the updated second edition. Every offshore project, we have similar supply chains. The main differences are the companies that are going to be involved. Whenever possible, it's usual to include companies close to the location of the wind farm. It is worth mentioning as well that every one of these categories can be subdivided into more specific activities. For example, within surveys, you can have geotechnical surveys, environmental surveys, etc. It is possible that during the first stages of a project, the same person will be responsible for more than one project at the same time, especially during development and consent, for example. But as the permitting process moves forward and the project becomes more complex, a specific person will be assigned to manage each project. But as you can see, they still have a lot of tasks to manage. So what are the main sources of our costs during a project? We can divide very simply into 3 general descriptions for study, report, certifications. In another area, materials, infrastructure, and construction itself, and our human resources. So what affects all these drivers? Time. As in everything, time is money. This is applicable to many everyday situations, but in this case, being offshore, it becomes more relevant as well. Aside from the time it takes for every step to move forward, as mentioned in previous presentation this week, we don't go out to the offshore wind farm when we want, but when the sea permits. So how can we reduce the time at different stages of the project? How will time affect our studies, reports, and certifications? So for example, in all these cases, you're mostly hiring a service. So the longer it takes for them to fulfill that service, the more money it will cost. It's as simple as that. So how can we reduce that time? For example, we can hire companies that already have expertise on that topic, and it's much easier and quicker for them to repeat the same steps they've already followed before. We can also share information that we have so that they don't have to reinvent the wheel every time we ask them for something. Remember, the company you hired is now part of your project as well. We can also follow existing guidelines. As long as there's some kind of specific guideline for a process, the work will always be easier and faster because everyone is following the same rules. How time will affect the materials, the infrastructure, the construction. For example, when making purchases, provide clear instructions on what you're looking for. When possible, browse a catalog of the components first to become acquainted with the elements that can be provided by the supplier. Though the supplier will be an expert on his own topic, he doesn't need to be an expert on yours. Planning is also important. A clear schedule of activities is needed to confirm the relationship between the tasks and how any delays affect them. And human resources, how will that affect every worker on the project? For example, having 50 people doing the work that could be done by 20 or 5 doing that same work is not the solution. When you're applying more resources than needed, there is a tendency to end up with more than one person repeating the work of another person. And when you have less resources, you end up spending a lot of time learning things that might not be needed again to cover the lack of knowledge. For every project, you will have to find an equilibrium between these two. A simple way to assess these situations is by training your personnel. The more topics they are able to cover, the better they can assess the situation and decide when external work is needed and when it can be covered with the resources available. The project manager can't work on its own. The feedback from the team is key. As mentioned during previous presentations this week, identifying the problem and applying the correct solution is very, very important. And not always the correct solution is a perfect one. Start simple, define the problem, and start using the tools you know. This image, for example, was used yesterday in a presentation, and it describes very well some of the issues we are faced with in offshore wind when trying to define the parameters for our calculations. But these are just the mitigation factors. We still need to add certifications, surveys, construction work, regulators, visual impact, and many, many, many more that affect the development of a project. So what tools are available? A project will require a lot of different tools and software and simulation apps and other applications during its whole lifetime. But every tool is as useful as the information that you add to it. Some apps can integrate every system within the company, from invoices to work orders and spare parts. The work of the project manager is to keep track of this flow of information and events within the system. For this to work, the people involved in every team needs to include all the information and also in a common format known to all. Those applications are very useful, and they're also usually very expensive. But in the meantime, we can still use other software. Most of the apps also can migrate data from Excel or other applications. So the first step is to pick one of the tools that you already have and explore it. I added 2 other common problems when working on large projects. One, to identify the audience that will be working with that information. And why is that important? You will be working with people from different backgrounds. You can assume they'll know everything you know, but that's not true. A phrase that may seem simple could end up creating a problem. For example, to the guard that is in the front desk, you can tell him, I am waiting for a delivery from company X. When it arrives, please send it to the warehouse. And to the maintenance crew, you can tell him, when the controller arrives, let me know. But if you mix them up, the controller, which is actually also the term used for the person responsible for controlling the budget of the project, could end up in the warehouse. Even though English is in many cases the main language for communication, certain technical terms could have more than one meaning. To identify the location is also very important. When you're working on a team that is distributed between different countries, working on shifts, and even with some contractors, you have to be concise and clear enough for anyone to understand it. They can't always call you to ask for details, unless you want to be called at 4 a.m. every morning, for example. Even a simple 3-color system to identify stages of each activity could be useful. Sharing information is important, but it also has to be clear. Remember, you want the work to run as smooth as possible to reduce time and therefore cost. What are you also looking for? you need a multidisciplinary team. During a conference a few years ago, one of the speakers was asked what skills were they looking for the workers in offshore. She said, we need MacGyvers. For those of you who don't know what a MacGyver means, and thanks to the reboot of the AT show, you can also check it in some streaming platforms. But what she was explaining was that for offshore operations, you have limited weather windows. So more than ever, time is of the essence. But you're also limited by space. You can't take 100 workers into the turbine. Everything has to be carefully planned, but things still happen. And you might need a tool that you don't have, or the technician that is on shore. So it's important that everyone on the boat has as many different skills as possible. If you don't know yet which area you want to keep working on, try different things. If you already know your path, try different things. You can never know if someone could give you your next great idea, or if they might need yours. The ocean offers the opportunity to work with all kinds of profiles. And this is an example of some job roles in the offshore wind sector. And there are many, many more. I will browse quickly over the list, but you can check the details on the link below. You can see you have people working on development surveys and studies, turbine tower supply. Don't be afraid to participate in events like the summer school that include different aspects of the project. You have the foundation as well, the cable. There have never been as many webinars as there has been the past year. Try checking webinars on biofouling, environmental aspects, even if it's outside your comfort zone. You have a substation as well, the turbine foundation. As a project manager, you will need to look at the project as a whole. Every single aspect is important. And health and safety is also an important issue in real life conditions. When you're testing your devices, you probably went through some basic training, but there's still a lot more to learn. Even if your passion is within the walls of the lab, you still need to know what your colleagues will go through at sea to make your estimations accurate. What I wanted to say now was value your work. Most of the speakers we've seen have already spent months, years analyzing information, reading from different papers, exploring and testing devices. And that all that information or that knowledge is really, really important. It's not just for research. Everything that you're able to test and to validate before it goes offshore, it means less risk for your future colleagues that will be there at sea. Good luck with your research, and I hope to see you soon in more activities of the consortium. Thank you for your time.
Thank you very much, Amorina, for this interesting presentation. I think we will discuss this presentation in the question and answer session later on. So now I think it's time already for Matteo Baudino Bessone from TU Delft. So title of his talk is Review on Floating Offshore Wind Farm, Identification of the Interactions Between Subsystems. I don't know if you want to wait. Well, it's already almost 3 o'clock, so I think you can make a start.
Yeah, I can start. I can take 1 minute more. Thanks, Daniele. And I hope you managed to see my screen now. Okay. So hello everyone, and thank you for being here on Friday late afternoon attending my presentation. My name is Matteo Baudino Bessone, and I'm, as Daniele mentioned, I'm a first-year PhD candidate at Delft University of Technology. And I'm also, my research is also part of the Step for Wind research program that presumably you have seen other colleagues of mine presenting at this summer school. So I won't go too much into detail. This is Horizon 2020 Marie Curie ITN that will train 10 early stage researchers working in many different fields and toward an industrial doctoral degree. And is also led in cooperation between industry and academia. And myself, I'm ESR number 4, so I'm located up here. And my areas of interest are floating, wind farm design, and system engineering and optimization. And the people I work with, let's say my supervisory team, come from TU Delft, where I work with Michael Zayer, Axel Vire, and Dominic von Terzi, or a catapult in Scotland with Ellen Jump, and also DTU in Denmark with Catherine Dykes. And today I will talk to you all a little bit about a review work that we carried out to identify where relevant interactions between different subsystems embedded in floating wind farms occur. So I will start from the motivation driving the research, then I will move to the methodology applied, and finally I will conclude with what I consider the main results, or the most interesting results. So beginning with the overarching view and moving then to more details, as we have seen, floating wind is field with a very high potential as it allows the exploitation of wind resource in deep waters. And the big advantages that are usually recognized to floating wind are that this opens the door to new markets, enables the exploitation of more abundant far offshore wind resource, and at the same time reduces the visual and environmental impact of the power plants. Forecasts for floating wind are also very positive, expecting a very significant growth of the installed capacity in the next decades, and together with considerable reduction of levelized cost of energy that is necessary to make floating wind a competitive source of renewable energy. And this presumably will also see the floating wind industry move from current small pre-commercial floating wind farms to larger commercial scale wind power plants. As floating wind is still quite novel, there are not yet these large commercial scale floating wind farms, and nor consolidated experience related to the design of these systems. However, for what concerns the design process, it is possible to draw some parallelism with bottom-funded offshore wind, where the design of this conventional bottom-funded offshore wind farms follows an approach which can be defined as sequential or partitioned or iterative, depending on the different authors, where different offices or companies take the ownership of a subsection of the design process. And even though this methodology has successfully underpinned the growth of offshore wind, it also has an inherent drawback as it overlooks interaction between different subsystems. At the same time, there is also growing evidence that the design of offshore wind farm could benefit from a more holistic systems engineering approach that allows to account for the interaction between different subsystems, and possibly in the end to obtain a larger reduction of the levelized cost of energy. And this could even be more relevant for floating wind farms due to the tighter coupling between the many subsystems that are embedded in floating power plants. So with the said, the objective of the review that we carried out was to identify where do these interactions within floating wind systems occur. So this leads us to the definition of a methodology to do so. While analyzing the literature on the topic, we observed that while there is a growing interest in the wind farm design in general, only a few works deal with the design of floating wind farms, which can be expected as it is quite a novel field. On the other hand, there are several studies that focus on specific subsystems or processes that are involved in the development, realization, and operation of floating wind farms. And this is again in line with the main sequential or partitional approach that is applying to the design of offshore wind farms. So how to carry out a literature review on something where there is no extensive literature about how to solve this problem? Again, it is possible to draw some parallelisms with conventional bottom-founded offshore wind farms, as some interactions typical of bottom-founded offshore wind will also characterize floating wind farms. This allowed to obtain a database of about 100 journal publications and also to identify relevant areas of interest that are related to the design of offshore wind farms that can also be applicable to floating wind. Also, other information can be collected from the subsystem specific literature, which is far wider, as I mentioned. At the same time, floating wind farms are quite complex systems, and there is quite a wide number of subsystems and procedures that are embedded in the design of a floating wind farm, and thus have to be accounted for. Furthermore, for all these subsystems, there are several concepts and design options that can be selected. And we try to categorize these concepts following a principle based on a functionality of each component and procedure. For instance, for the power production category, even though horizontal axis wind turbines are the dominating design options, vertical axis wind turbines were also considered, as they could have some beneficial features for floating specific applications, and there was also work in the past on hybrid systems combining wind and wave energy converters, or in the possibility to co-locate wind or wave farms. Finally, again, drawing a parallelism with conventional offshore wind, it can be expected that there will be several actors involved in the design, construction, and operation of future large-scale floating wind systems. All these actors have different interests in the project and look at it from a different standpoint, and their involvement in different project phases and subsystems is also quite different. For this work, we adopted the standpoint of the project developer / operator of the farm, as it is considered a central player, which is also active in most of the phases of the project. But this means, for instance, that we considered, for instance, the wind turbine as a single subsystem, and we did not focus on the main turbine components, as we assumed that the integrations of the two main components within the wind turbine system will be a responsibility of the wind turbine manufacturer. So this leads us to the identification of these interactions that we portrayed using a design structure matrix. We opted for design structure matrices as they are a well-established systems engineering tool that provide a flexible and practical method to display relationships in complex systems such as floating wind farms. The way design structure matrices work is that disciplines, or in my case, the categories that we identified, are enumerated to the left of the matrix and inhabit the diagonal position in the respective row, while feed-forward relationships are represented above the diagonal and feedbacks below the diagonal. So to provide an example about how to read the design structure matrix and to walk you also through it, The design of the station keeping system is affected by the layout of the wind farm, as water depth at each turbine position contributes to determine the mooring line length, while concurrently, the footprint of the station keeping system can become a design constraint in deep waters and thus constrain the overall layout design. Furthermore, the maximum allowable drift for dynamic cable can become a design driver for the mooring line design, where at the same time, maximum excursions of the platform is a design driver for the cable. And so here there is a trade-off, as minimizing the allowed excursion will presumably minimize the cost of the cable, but will most likely not minimize the cost of the cable and mooring system altogether. Furthermore, designing mooring systems that can be efficiently connecting and disconnecting to the platform over 20 and more years long life of a wind farm will allow to enable towing the platform turbine to the harbor for maintenance, which in turn will affect the operational expenditure and thus the levelized cost of energy. So among these interconnections, a very relevant one is definitely the one between turbine, floating substructure, and the station keeping system, where the floating substructure and station keeping system are usually designed to meet turbine specifications. And the turbine instead is to be adapted for floating specific applications. Furthermore, the choice of the floating substructure largely also determines the choice for the mooring lines. And so embedding in this design problem, we can see a trade-off between larger turbines and thus possibly higher energy production and lower maintenance cost for equal farm capacity. While on the other side, we have a higher cost of the substructure that we have to balance. Relevant coupling lays between the definition of the layout of the wind farm that affects the topology of the field cables or power collection system, according to the categorization I introduced before, which is in turn affected by the number of and position of offshore substation. And this is an interaction that, for instance, is also typical of bottom-funded wind farms. And the underlying trade-off is between the cost of the electrical system and energy production. So in the picture below, you can see what ideally would happen if a designer wanted to maximize only energy production in a farm. Then he would, we would obtain a layout which is as wide as possible, but this will be traded with higher cable cost. While if the same designer decided to minimize electrical balance of system cost, the layout of the wind farm will be clustered around the substation with turbines as close as possible to minimize electrical cable cost. But this will cause a lower energy production in the end due to wake and dust losses. So another trade-off. And the third relevant interaction is between the platform design and manufacturing cost, installation and O&M cost. With different platform concepts having better performances in different aspects. For instance, Powerbuoy have a relative advantage when it comes to manufacturing complexity, while semi-submersible have a relative disadvantage. On the contrary, when it comes to installation, the situation reverts, with semi-submersible having a much easier deployability, while Powerbuoys are limited by the deep draft. And tension-leg platform suffer due to an inherent lack of stability when mooring lines are not connected, even though the most recent TLP designs have adopted some smart solutions to overcome these issues. However, the main point of this slide is it is very important when deciding for a platform design to take into account both manufacturing, installation, and O&M cost. And this is a little bit also the area where I'm currently working on to building a model to account while designing floating platform, accounting also for O&M and installation cost. And yeah, we'd say that I thank you very much for attending the presentation. And I think if you have questions, now is the time to try to answer, and otherwise you can also contact me at my institutional email. And I added a few references here that I use for building the presentation. So thanks a lot.
Thank you very much, Matteo. So we open now the question and answer session. I received during your talks 2 questions, so one for each of you. So let's start from the question for Amorina. Would you say that there is a shift towards more technically inclined project managers in the field of floating offshore wind turbine due to the multidisciplinarity facet of the field? So I think the attendee wants to know if the profile of project managers tends to be more technical nowadays than it used to be in the past. Because of multidisciplinarity. So
in general, a lot of project managers come from the engineering fields, but that doesn't mean that there are other people who are successful, who build their own companies and come from other studies. One of the companies that is actually currently working and is being successful in Tidal, the owner comes from art studies. So that's not common, but it doesn't mean that you can't do it. In general, a project manager has to be able to be multidisciplinary. Whether, of course, if you start from a field that gives you the knowledge for, especially for offshore wind, if you start from the naval sector or maritime sector, you will have an advantage over the rest because you will have a lot of internal knowledge that you gained previously during your career, and will put you in a better position against other contestants, but it doesn't mean it's impossible.
Okay, so yeah, I guess probably some technical lack of knowledge and preparation can be always compensated by experience. That's for sure. So I have a request to integrate this question by Likita. So does Likita want to contribute to this? Probably
no, I think it's just to answer the question because
okay.
when you're answering it live.
Yeah, but I have an additional question to ask on the same question. How different is project management in onshore as compared to that of offshore wind industry? Could you just highlight something on that, Amorina?
I don't think, I mean, whether it's onshore, offshore, renewables, or oil and gas, you always have the same issues, which are managing a lot of people, managing a lot of information. Regarding offshore, you have to be always keeping in mind the conditions that you will have and sending your people outside. So possibly regarding health and safety, there are going to be a lot more issues that you have to take care before sending anyone to the farm. And when you're onshore, there's always something that you can call someone at any time. They can just pick their truck and get to the site, and you are not able to do that. So possibly planning is also one of the greatest issues. You have to be thinking in advance and planning in advance as much as possible. There's not, if you don't have a vessel when something breaks down, and in many cases you have to book that vessel with months in advance as well, you won't be able to have the materials, you won't be able to do the work. So planning, health and safety, I think, are basically the most important differences. I don't know, Matteo maybe has other issues to add. I'm
not a great expert in project management, I have to say. So I was also listening to your answer with a lot of interest.
So I actually, listening to this presentation made me also made me come to my mind some questions as well. So I guess, considering that the field is relatively new, how can a manager take into consideration, for instance, health and safety, and how can lack of regulation affect the work of a manager, of a project manager, because I think this is as I said, like a relatively new field, and probably there is still some lack of regulations and laws. Or how can you comment on this?
Okay, so regarding the health and safety, even though floating offshore itself is new, and especially in a lot of countries, these are the first times that we're even considering having offshore wind, because fixed offshore wind was impossible. But there's a lot of experience already from the oil and gas sector. Most of the workers from oil and gas, a lot went later into working for fixed offshore wind farms in the North Sea. There is a lot of information there. There is an issue now with a lot of countries from Latin America getting involved and moving forward with offshore wind, which is that most of the information is in English, but to reach the people, you have to translate it. But it's not the only place. Korea is moving forward a lot with floating offshore wind. They're probably having to translate all that information into Korean as well. But there's a lot of experience already in offshore. There is, as you say, a lack of regulation, and that is a really important issue, not only for health and safety, but for other things. Or even now with the Brexit, we had an issue in a project where the prototype was before the Brexit in another country, being tested within a program, and after the Brexit and after the COVID, when trying to move that same prototype back to its own home in the UK, there are no regulations and no paperwork to specify what to do. So they were trying to ask them to pay for taxes that when it didn't make sense. So there's always new regulation that has to be made. It is important, and the maritime sector in different countries has been pushing to have detailed assessments of what to do, who is responsible. The insurance, not just specific companies, but the insurance sector is also something that has to get involved, and they also have to be a part of the discussion and demand that regulations are made, because when you're moving offshore, you are not a fisherman. So if you have an accident, the fisherman's insurance won't cover you, but you're not, if your country didn't have oil and gas or any other industry similar to that, you're in the middle of nowhere. So, and those kind of things have to be defined. Of course, they always move slowly, but each country, when they start working with offshore, they have to start involving as many stakeholders as they can, including people from the ports, including fishermen, and everyone that is currently working on that area is also very important, because they know all the issues that happen there, and they know how to fix the problems. Here in Portugal, even the fishermen are working as part of the guards of the and monitors of the plants. So the more stakeholders you involve, the more issues that will arise during the discussions, but the easier it will be, so that when the project is actually happening, you will be able to solve all those problems before, and not just suddenly bring a floating offshore plant and try to figure everything out. Like,
very clear. Thank you very much. So there is also another question that I think for Matteo, probably. Yeah, so Matteo replied to this already in written form. So is it accessible to everybody, the answer? I believe, yes. Well, I think it's probably worth still expanding on this. So I posed the question. So considering the large diversity of your design structure method, is DSM, right? Matrix, sorry.
Yeah.
The design structure matrix, how do you choose the data that you will incorporate and what to ignore, keeping cost and simplicity in mind? And do you want to elaborate on what you wrote?
Yeah, sure. I assume that the data, it's the number of concepts and the cost and simplicity is related to the complexity of the analysis that are applied to different concepts. And well, of course, starting from what is perceived as the most common application for the future is the way there is no point of having a model that take also, for instance, floating vertical axis wind turbines if you don't have a horizontal axis wind turbine, or maybe it's less relevant. And for what concerns computational cost and analysis is, I would say, starting from simpler analysis models, and then see how they work, predicting a levelized cost of energy, and then upgrading if necessary, and see where the upgradings bring you, because in the end, what is really relevant is getting reasonable, at least levelized cost of energy estimate. So I hope this answers the question.
I have a follow-up. That's okay. Yeah, I can ask a question. Daniel.
Sure.
Yeah,
for sure.
Matteo, just a follow-up. So I see that you had, for example, in your design structure matrix, 10 sections. But of course, within each section, you could also have multiple, let's say, subsections. So when you are right now looking at these interactions or trying to characterize the contribution of each section, do you then have to, in a similar way to the data, do you then have to choose what to give priority to, or do you get data in such a way that all of these are already, say, pre-optimized to give you something that you use for your design structure matrix? How does it work? Because I can imagine there will be a lot of different subsystems that come into play when you look at a floating offshore wind turbine.
Yeah, you have to decide how deep you want to go and how in detail there are different, let's say, MDIO framework for floating wind that are out there that have different level of detail. You can have a very, for instance, I don't know, you can have a very simple turbine model that is just a cost model that returns you a cost of the turbine. You can have a very detailed instead turbine model that actually embeds aerodynamics, structural, and hydrodynamics. So there is, you have to balance with time and cost.
Okay, thank you.
Welcome.
Yeah. Okay, so if there are no other questions, I will have personally a quick one that comes from the current situation in the markets. So prices of commodities have recently increased dramatically. So I'm wondering, how can you compensate for these increases in your matrices and in your cost estimates in general? So if you make, for instance, a long-term plan for an investment, you have that the prices of commodity are really affecting these estimates. So do you, I think this can be a question for each of you. So any of you wants to comment on this in 3 minutes, and then we move to the next?
I just want to add one comment that if you already have the funding, whether it's from a bank or an institution, you will probably have to renegotiate the funding options and all your costs. It depends on how much those variations are really affecting your budget, but in certain cases, you might need to refinance the project.
Okay, interesting. Matteo, do you want to add something on it?
Yeah, I'm not sure if I understood the question. If you mean if your, for instance, your investment cost estimation is.
I'm talking about really the prices of commodity. For instance, like copper for cables,
okay,
or other materials that nowadays, with this transition into renewable energy, have experienced a huge increase. And this is really in the last few months, after this Green Deal has been launched by the European Union, for instance. This is how the market reacted on it. So I wanted to know if there is something in relation to this, that cost management react as well accordingly.
I mean, in my model, cost of raw material is a parameter, user specified a parameter that user
Okay.
can specify, and yeah, but I don't have any, let's say, estimate. I don't do any future estimate on cost of material. Of course, during the time of the project, you have to refine and adapt your estimation that you did, considering that they will last maybe years. So.
Okay. Okay, then we can close this session, and I think we can go back to the talk of Rodrigo Rojas that was originally planned at 2:45. So Rodrigo Rojas is a coordinator at the Institute of Electricity of Costa Rica, ICE, and is also professor at the National University of Costa Rica and part of the educational board of the ENCORE project. So I'm not sure if Dr. Rojas is.
I'm here, my friend Daniel.
Yes.
I'm here.
Okay, so
you hear me?
The floor is yours.
Yeah, thank you. Daniel, let me know if you see my screen, please.
Yes, very well, and we can hear you.
It's in full presentation.
No, if you click in that point,
all right.
Yes. Now it is.
Okay, Daniel. Well, thank you very much to my friend Amorina and Pranan for inviting me to, I will say, to share some advance in the offshore wind research here in Costa Rica. And the perspective that I would like to present today is not based in answers. More, I would like to present my discussion more in questions, because now here in Costa Rica, we have more questions than answer. But it's okay. Now we are full discussion inside of the country. What is the main way to move forward into the use, the challenges, the gaps on the development of offshore energy in general, and of course, offshore wind potential is for Costa Rica a milestone for integral country development. For me, it's yeah, of course, it's a pleasure to share this some results, some advance in regards what the Costa Rica have in the offshore wind roadmap. But first of all, I would like to put some hits, some milestone of what is located Costa Rica. As you can see in my screen, Costa Rica is in the middle of the American tropical belt. In the north, you have Nicaragua. In the south, you have Panama. In the west, you have Atlantic, and the east, you have the Pacific Ocean. The country is very important for us to say that. The country is one of the greenest nations with 27% of the continental and marine territories is protected under conservation areas systems. And yes, why not to say that currently features greater biodiversity than Europe or North America. Why we say that? Well, because it's very important to put in the correct way, in the correct frame, how is the energy development here in Costa Rica. In this regard, is very important that all international audience in this summer school know that Costa Rica has a very important commitment on renewable energy. in the last, I will say in the last 5 years, almost 5 years, Costa Rica has been achieved its energy based on 100% of electricity production from renewable energies. We have a very strong energy and electricity matrix based on, as you can see in this slide, as you can see, 68.6% of the energy coming from hydropower. And we also include the participation of the wind, geothermal, and a minor participation of, in this moment, of course, of biomass and solar. But very important for us is to move forward in the target to keep as resilient energy matrix. For this, Costa Rica has made very important compromise around the world against climate change, and moving to try to have a very competitive energy transitions. This is why we are thinking in the last year to change from continental energy portfolio to looking for marine energy portfolio or marine energy patrimonies. Of course, we have a very good onshore potentials. This is why in this moment we have an electric matrix very powerful, with a connected grid around the world, around the country, sorry. But this is why we need to prepare for the near future. We need to change to a more resilient matrix, electric resilient matrix. And in this regard, government of Costa Rica, NGOs, academia are joined to moving forward to boost the use of marine energies. And in the first place, I will say, in the first place, the offshore wind is our first compromise. You can see, look, this slide is very significant for us. You can see the electric portfolio who have different characteristics, is diverse because have hydropower, geothermal, solar, etc. Is sustainable, is coming from renewable energies, is resilient against climate change. For us, is the low cost analysis. And very important thing is almost all the country have access to grid. Not only mountains, not only in coast, but all the country have access to the grid. However, look, when we are speaking about offshore installed capacity, there is some contrariety, because we are 10 times more marine territories than continental territories. You can see the map. However, in this moment, currently, we have 0 kilowatts coming from marine zones. This is why we are thinking, well, if we have a very good, a very well electricity energy, what happened with the offshore capacity? And in this regard, Costa Rica represents a core of the, I will say, literally thousands of megawatts of non-conventional offshore energy available, not only in Pacific, but also in the Caribbean coast. under these concepts, under this situation, the question is why Costa Rica is not moving forward to use the offshore, at least offshore wind potentials. Yes. And in this discussion, since 2012, Costa Rica has been coordinating several actions, not only for to have a strategic plan for non-conventional energy, but also operative, not only a strategic, but also operative plan to try to use in the near future the offshore energy, in this case, offshore wind potential, for as a part of the portfolio of non-conventional energy of Costa Rica. The first looking, I understand that this summer school is on offshore wind. This is clear for me. However, as a historical perspective, Costa Rica start in 2013 to work with research on wave energies. And the Portuguese enterprise company, who my friend Amorina is represent here, is WavEC. Carry out the first study to know the marine energy potentials here in Costa Rica. And this slide is in some way the results on that. But in 2018, start officially the research on offshore wind potentials. Well, the main purpose to moving forward to try to use in the near future the offshore wind potential is because we have unexploited 14 gigawatt expecting for the Costa Rican developments. As you can see, now we are I would like to introduce some basic result. We understand the level of the research. We understand that many have many challenges, many gaps to fulfill, but we understand that this is the first step for us. And under this perspective, is very important for the Costa Rican taking decisions to know where is the potential, how much potential we have, what is about the social acceptance, what is about the legal and environmental license, what is about the cost of energy. And regarding all these issues, this is why we are building up a portfolio of energies, a portfolio of research. And in my screen, you can see some results about that. As you can see, between 2018 and 2020, we carry out some specific research in the North Pacific. North Pacific is a characteristic zone that the wind speed is, I will say, uncomparative to take in account many sites, many places around the world. We have very competitive wind speed to think in a real offshore wind industry development for the next decade here in Costa Rica. As you can see, we are moving to try to make answers in many, I will say, meta-oceans investigations, researching in supply chain. As you know, we need to know what is the current status of Costa Rica in issues as infrastructure, consenting process, environmental viability, grid, transmission. And this is why we are starting the process to geological research in the Pacific North, geophysics analysis, and also, of course, what is the environmental and the economic and social restrictions to will need to take into account to the near future development for my country. Now we are working in prioritization on some specific offshore wind areas using the method called multi-criteria analysis. This multi-criteria analysis take into account some criteria selected, as you can see: bathymetry, environmental conditions, landscape perspective, social and economic frame, and also wind speed analysis. And you can see in my screen in the side right, you can see the different maps and the integration to try to know at the end what is the final potential energy areas who can use in the future for the installed capacity of the offshore wind in North Pacific. Here is, I will say, the integrated map of the potentials of the offshore wind, and also potentials of energy that you can willing to use for Costa Rica energy development. This is a cluster in the circle. This is a cluster very, very important. It's a permanent cluster where you can see speed biology, wind speed in between 8 to 10 meters per second. Is very, very significant, this wind speed. And you can see the profile of the offshore wind speed at 120 meter high. Currently, we have a tower, a monitor tower in Salinas. You can Google Bahia Salinas. You can Google Bahia Salinas in Costa Rica, and you can try to see where the monitor tower is. And also, as combined information, we are using satellite information in the study area. And you are the expert. I understand that, colleagues. You are the expert. I am a project manager, but you know how is calculated the exploitable energy area. And this is the formula that the expert, as you, as the audience here, are usually to use to calculate the density of the wind power. I'm not getting in these details because I understand that we are between engineers, we are between people who are familiar with that. But my idea with this slide is to show some relevant information about the potential of Costa Rica and the way to calculate this one. So in these issues, in this regard, it's important to remember that at the level of the technical potential, we have a huge amount of energy waiting for us, with an annual energy very competitive, and the power factor very, very important to assume in the near future eventual deployment or eventual project there. As mentioned here in the North Pacific, very close to the border with Nicaragua, we have as we said, a permanent plume with a superior offshore wind, with a very high power factor, with a technical potential very competitive, to think that Costa Rica have very clear, very positive future in the offshore wind development. This is a layout. I'm not expert, but this is a layout on a draft of the offshore wind turbine distribution in the exploitable area. You can see that we are in advance now. We are we are drawing, we are modeling, we are simulating how will be the layout of the wind offshore wind farm in the place. This is a draft. Of course, colleagues, is not definitive. It is a draft. This is the many things we are planning, many things we are thinking, many things we are taking decision about how is Costa Rica moving into the offshore wind development market, developing industries. But not only for floating system, floating technologies, but also we have very important significant installed capacity of fixed bottom wind turbines. You can see the data. We have 540 megawatts of technical potential, very well, an annual energy. And look the power factor. Power factor is very attractive for escalate, for take decision in economic and also economic scalability of the project. And moving into the planning, what is the next step for both the roadmap of the development of the offshore wind in Costa Rica? Well, as you can see, I can share with you at least five main milestones from I will say from last 10 years. In no less than years, eight years. In the first, WavEC helped us in the 2013 to help us to determine marine energy potentials. And from there, we are keeping researching on that. In last year, we have a very, very good international conference who invite more than 200 specialists, 200 international specialists to come to Costa Rica to share the main advances. Not only, I need to be honest, not only in offshore wind, but also in currents and in tides, in wave, in etc. In all the world of the marine energy issues. And last year we finishes the Punta Descartes offshore wind project. Now is in the phase of identification. Now in my presentation, getting in more details. And now this year, we are working together with Global Wind Energy Council, is Europe institution, Europe company, Europe enterprise who are leading the offshore wind development around the world. So we are working with them in order to create the first roadmap here in Costa Rica. Why? This is I would like that you take some seconds, some minutes to read this slide. This is one very good reason why Costa Rica are thinking to include offshore wind energy for the future portfolio. We need to move forward in decarbonization and economy, decarbonization of the economy, and try to move forward the electricity transportation. And under this role, not only continental energy current portfolio will be necessary, but also we are thinking that a very good participation from offshore wind could be complementary, could be very important, could be key role into the development of these important issues, not only decarbonization of the economy, but moving forward to electricity transportation strategy. And we are thinking that the energy coming from the marine areas will be very important to move forward in these important goals. Speaking about challenges and the opportunity, we have many challenges. Now we are trying to to looking for funds. We are trying to looking for engineer specialists in these areas, because we are, to be very true, we lack of this kind of people who have very well known in regards of the offshore wind industry. The challenges, well, the most important is the current national plan of decarbonization needs an installed 4.4 gigawatts of renewable energy for the next 3 decades. So we need to fast. We need to move fast. We need to take as soon as possible decision on that. We have a very good opportunities, because offshore wind can play a very major role in this plan. But also, this is very important that we share with all of you. In spite that Costa Rica are not specialists in offshore energy, we have a national team who are working, who are supporting the offshore wind development agenda. As you can see, there are members from Costa Rican Energy Minister, all 5 academia university representing Costa Rica, NGOs, even private enterprise. So we have a very good cluster of colleagues who are concerned, who are working on offshore wind development. Here you can see the last meeting that we have. I don't recall. Yes, I recall Amorina was there here. And we have very international connections with colleagues from all Ibero-America. Ibero-America means Portugal, Spain, and Spanish-tongue countries of America. So Rodrigo, what is the strength for both the offshore wind plant in Costa Rica? You can see a list of many strengths that the Costa Rica have already. Energy efficiency, in all the country. We have specialists in oceanography. We have people who know numeric modulations. Now, I will say we are renaissance infrastructure. We need to work on that, but we have specialized people in marine ecology, NGOs vinculated to marine areas, marine planning processes, basic port infrastructure, blue economy plan support, and we are thinking in strong the marine and coastal planning, looking for a place for the offshore wind development. Police, what is the next steps and gaps to overcome? Well, offshore wind plants in the marine areas need at least governance. In this moment, there is a non-governance marine planning in Costa Rica. So we need to work in marine governance. We need to work in field databases. We lack, unfortunately, of many field data information to take strong decisions. We need to invest in floating LiDAR as an advanced offshore wind speed measurement techniques. LiDAR is one of many, but for instance, we need to put this kind of techniques. We are very weak in this area. Costa Rica lack, not only in Caribbean side, but also in Pacific coast, lack of very good coastal infrastructure to moving, to boost the offshore wind development. So we need to work in coastal infrastructure. Also, we need to work in the new generation of experts in offshore wind supply chain. Supply chain for us is very important. By the way, just 2 weeks ago was published a first paper on supply chain here, offshore wind supply chain here in Costa Rica. if someone are interesting, I'm willing to share the paper and results. Thank you very much, Pranab. Thank you very much, Amorina, for the invitation to very nice summer school. Thank you.
Okay, thank you very much to Dr. Rojas.
Thank you too, Daniel. Thank you too.
No problem. So now the presentation is open for questions. I see already Amorina as one. Please go ahead.
Okay. Okay. Yes.
Hi, thank you. One question regarding the supply chain. Are you considering synergies with other countries that are close by? Or because, I mean, in Europe, we already know there are certain countries like the UK that have even supply chains per areas because of the amount of offshore wind farms they already have there and the network that they formed during the past years. But for example, here in Portugal, when I was building mine for TWIND, we found a lot of synergies with Spain. In general, the peninsula can help each other. Both Portuguese companies can work in Spain easily and Spanish companies in Portugal. Are you considering as well synergies with other countries, or are you planning more on trying to build a supply chain for Costa Rica only that?
Amorina, you can see me. I'm not sure if my camera is going.
No, I think
no, we cannot see you, unfortunately.
Okay. Please just 1 second. Okay, Amorina, yes. Nice to meet you. Okay, very good question. Unfortunately, I have to say that unfortunately.
Rodrigo, I think we're having some technical issues. Maybe it's better if you take off the video so that there's better internet connection.
Well, no.
Can you hear us, Rodrigo?
Me? I should off the camera. Sorry. Yes. Daniel, do you hear me?
Yes, now very clear.
Oh, okay. So my answer for Amorina is the next. Amorina, Costa Rica have different energy development taking into account the Nicaragua and Panama. For this moment, we are moving as we are not thinking to include another border country. We are thinking to moving only as Costa Rica, not thinking to join with the energy perspective of another countries. And the reason is very clear. Costa Rica from decades ago take different decisions to Panama or to Nicaragua or to Guatemala or to Salvador. And now we are very different in regards energy issues. The way to produce energy in Nicaragua, the way to produce energy in Panama is different than in Costa Rica. This is why we are not to think in join to another countries. We understand, Amorina, we understand that supply chain is quite difficult, but in this moment, we are moving as a country-owned country.
Okay, thank you very much. I think these answers
Daniel, I think that I have a question here.
Please.
Yes, some anonymous attendees.
Ah, yes.
Yeah.
Yeah, I'm about to read it. Okay, yes. So if Amorina's questions is answered satisfactorily, I want to move to the question from the audience. So, hi, Rodrigo. Thank you for the presentation. As you mentioned, historically, offshore wind research and development has been driven from Europe. Do you believe enough is being done to share this expertise with the new entrants to the market? So
yes,
they want to know if you receive enough support from countries that are leading in the field.
yeah, Daniel and colleagues, thank you very much for the question. It's very important. Now we are building a kind of a bridge between America and Europe. We are now, especially in the last, I will say 2-3 years ago, we are working with many companies. We are closing with many universities and academia from Europe in order to moving forward into offshore wind industry in Costa Rica. So in short, my answer is yes. We are very well collaborating with Europe companies, Europe academia, Europe colleagues. We are bridging, we are closing, we are nearing with the specialists on this regard.
Okay. Are there particular universities that are your partners? Perhaps?
Yeah. Very good questions. Now we are very close. I don't know if you are familiar with University of País Vasco in Spain.
Yes.
This is one example. The another example is the Anchor project in the Plymouth University. Oh, my connection isn't stable, Daniel. I'm sorry.
Yes. Yeah. No worries.
Are you hearing me?
Yes. Now, yes.
Oh, okay. And we are working with a specialist from Plymouth University from UK.
Yes. Okay. Nice. So are there more questions from the audience?
Just one. When do you think the roadmap will be finished and published?
This year, Amorina, this year.
Okay.
Pranav, end of this year. Pranav, I need to ask you a favor, please.
Yes, of course.
Could you speak slow?
I will try. It's been a problem. Yeah, so I have one question more about the background of Costa Rica. So in Europe, a lot of the offshore wind energy research has been driven from, for example, oil platforms and other offshore energy fields, let's say. What is Costa Rica's background when it comes to these kind of fields, and whether do you think you can draw some data sets or things like that from these fields to complement your own new roadmap?
Yeah, very good question, Pranav. And fortunately, I understand you. Sorry. Yeah, but you know, Costa Rica don't have any kind of platform for oil or gas uses at the moment. We don't have any kind of this, and the infrastructure for the offshore wind development is very basic. I will say very basic. The ports, yeah, basically the ports is need to make a reconversation in order to use as eventual future platform or etc in offshore wind development. In short, Pranab, we don't have very good infrastructure. This is one basic step for the roadmap development of my country.
Thank you.
Okay. More questions from the audience? So I have a question myself, actually. You showed at some point a map with the wind velocity typically on the country. So it seems that there are large areas in which it's possible to reinforce the installation and expand the installed potential, the installed power of wind energy, even onshore. So how is Costa Rica dealing with this at the moment? And I mean, is there any plan to expand first the onshore rather than moving already offshore, or you're thinking of, I mean, the country is thinking of?
Daniel, this question is very good. This question is very good. At the moment, this is one of the main discussions. Why, if Costa Rica have very onshore potential, why are thinking to exploit the offshore? This is the questions. You follow me?
Sure, yes.
Yeah, okay. So, but the point is not, the perspective for us is not getting in this kind of discussions. The point is, why not now to take decisions to develop in the future the offshore wind? To try to use the offshore wind potential in Costa Rica is not to take 1 year, not to take 2 years, not take 3 years, take many years. So now is the moment to take decisions on finance, to take decisions on study, to take decisions on database. So meanwhile, we are exploiting, we are using the onshore wind potential, but using, thinking that we can use the offshore wind potential in the near future. When? 2 decades, 15 years ago. You got it?
Yes, very clear. Okay. So maybe I missed it. So what's the percentage of total production of electricity? What is the quote coming from the onshore wind energy then?
15% of the electricity, yes, 15% of the electricity matrix coming from offshore wind. Onshore
wind.
Onshore wind. Yes.
Okay.
Okay.
It's quite a lot already. Okay, more questions from the audience? I think people are also a bit tired after 5 days of presentations. Okay, so Pranav, do you want to?
Yeah, well, thank you so much, Daniel, for hosting the session. And thank you so much, Rodrigo, for waking up this early in the morning and joining our summer school, as well as giving the presentation here. It was very nice to see you and to hear you talk as well.
With that, thank you very much for the invitation. Thanks a lot. I truly appreciate, because this is the window that Costa Rica can use to show how it's moving forward into offshore wind development. So to you, to Amorina, thank you.
Of course, most welcome. Well, with that, I think we've now come to the end of the summer school. Axel, I believe you have some final words.
Yeah, I mean, very quickly, I'd like to thank you all the speakers today, but also the previous day for participating in this summer school, and of course, all the attendees. I think we got a good number of participants throughout the week, and we had really nice discussions, I think really nice Q&A sessions. So really thank you to everyone for that. Also a special thanks to Pranav, because I think he deserves all the credit in making this summer school really run smoothly. So all is, yeah, you organized everything, Pranav, basically. So thanks a lot for that. I think maybe you want to say also something, Pranav, about the recordings, right? I think maybe we can say a few words about that.
Yeah, so I mean, I've had a lot of interest from a lot of the attendees that they would like access to the recordings as well as the presentations. So these will be made available. The mode of which it will be made available is yet to be decided, but ideally next week or at most by the week after, all the attendees and the panelists will be getting an email with information on how to access the recordings as well as the presentations, as well as a feedback form to know how we did in the summer school as well.
Yeah, indeed, we will distribute that as well. I think it's always nice to have your feedback so that we can improve. Maybe worth mentioning that, yeah, as part of the TWIND project, we will also organize a short course that's probably be restricted really to the TWIND consortium. So any feedback on this event might help us as well for the short course coming up in the autumn.
Axel, can I have a word?
Yeah, go ahead, Rodrigo.
Thank you, Axel. Look, this kind of summer school is very important for emerging economy as Costa Rica, because it's the only way that international audience know about our agenda here in this side of the world. So this event is the unique opportunity to have a discussion, a talk on how is this small country moving into renewable, non-conventional portfolio of renewable energy. And for us, for me, is significant to attend this kind of international event, because it's important that international students, international universities know what is the role that Costa Rica are playing in the building of the energy renewable energy matrix. This is why I'm always looking for attend this this kind of the meeting. So Axel and Pranav, thanks again.
Thanks, Rodrigo. It was really our pleasure to have you also today, and that you could make it, as Pranav said. So yeah, so I think that might close our summer school. Thanks again, everyone. We'll be in touch for next week for the recordings and so on. I'd like to thank also all the people in the background, like Daniele and others who moderated, hosted, and co-hosted as well as backup this event. So thanks, everyone. We'll keep in touch and have a good weekend. Bye.
Thank you.
Weekend, everyone.
Thank you.
Bye-bye.
Thank you.
Thanks.
Bye.
Thanks a lot.
Bye-bye.
Bye.
Thanks, everyone. Bye.